Okay, I am talking about alternating series. An alternating series is any series which alternates between positive and negative with each term. And they usually take this form. Infinite sum of minus 1 to either the nth power or the nth plus 1 power times some second function a of n, where a of n is always greater than or equal to 0. Or I guess always greater than 0, yeah. And you can see why this would alternate back and forth. And what this series, or what this test says, is that if a couple of conditions about a of n are met, two conditions, then this entire series will converge. So what are these conditions? Well, a of n must be decreasing, and the limit as n approaches infinity of a of n must equal 0. So a of n must go to 0. Now, a lot of series that aren't alternating, as an example, the harmonic series, meet these conditions on their own. And they don't converge, they diverge, or the harmonic series, at least as an example, diverges. So, but if you look at the harmonic series inside of an alternating series, it would converge because, a of n would be the harmonic series and it meets these criteria, and so the alternating series test would say it converges. And that might be conceptually a little bit difficult, but I think there's a cool way to think about it, which is to write out the first couple of terms, and I think we should use the harmonic series as an example. So the sum from n equals 1 to infinity of minus 1 to the n plus 1 times 1 over n. So let's write out the first couple terms. At n equals 1, minus 1 squared times 1 over 1 is just 1. Next term is minus 1 to the third, is 2 plus 1 over 1 half, so minus 1 half. It's alternating, so we can kind of just ignore this and have it flip signs. So plus 1/3, minus 1/4, plus 1/5, minus 1/6, plus 1/7, minus 1/8, etc. And if we group every two together, group these two together, group these two together, group these two together, group these two together, we rewrite this as 1 minus 1 half plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7 minus 1/8, which is identical to this. You could etc. You write it on, and we do a little bit of cancellation. So this 1 minus 1 half turns into 1 half, plus 1/3 minus 1/4 is 4/12 minus 3/12, which is equal to 1/12. All of these are positive, you see. 1/5 minus 1/6 is 6/30 minus 5/30 is 1/30. This is 8/56 minus 7/56, which is 1/56. All right. Oh, we notice a pattern. So remember, this is the first two terms, the third and fourth term, the fifth and sixth term, the seventh and eighth term. So this, the little pattern emerges, which is n squared minus n, or 1 over n squared minus n. Each of these is that. So this is the first and second entry, so we plug in 2, and this is 1 over 4 minus 2 is 2. So 1 half, that's true. Well, this is the third and fourth, so we plug in 4 in here, and it turns into 1 over 16 minus 4, which is 12. Yep. So if we look at this series, this does converge, and it's kind of easy to see why. It's similar to a power series, and you can see why this would converge. It decreases a lot faster than the harmonic series, which is 1 over n. And remember, this is just a rewriting of this series. We're just, simplifying some stuff. And that might conceptually make it easier to understand. But that's alternating series tests.